Okay, so in the last video, we talked about how to convert from polar to rectangular. And this time we're going to talk about the opposite. We're going to talk about going from rectangular to polar. So there are like two, maybe three-ish conversion factors we need to remember here. So if you have a coordinate that's x, y, and you're trying to convert to r theta, what you're going to do is you're going to find r first. So r is just the square root of x squared plus y squared. And that's cool, that's no problem. Now finding theta is a little bit quirky. So the standard way is to not actually write down what theta is, but write down what the tan of the theta is. And the tan of the theta is y over x. Okay? So you want to find a theta that makes this true, that makes everything work. And you'll see what I'm talking about here in a minute. But for our purposes, you might be tempted and justified to find that theta is something like the arctan of y over x. And I say something like the arctan is because it could give you a wrong angle. It could give you something in the wrong quadrant, because if we remember arctan's properties, it actually gives you things only between negative pi over 2 and pi over 2. So if you get an angle over here, but your point is supposed to be over here, you need to do some adjustments. Oh, and we will probably not be using radians for this. I believe that we are going to be asked to be using degrees, so this is between negative 90 and 90. So arctan only gives you things between these two things, which means that if your point winds up on the other side or even down here, maybe something quirky is going to happen where you have to adjust it. Okay, so let's just do an example and see what happens. Okay, so the first example here is pretty basic. We have the xy coordinate 3, 3, and this is x and this is y. Now I pretty much always like to graph in some basic sense what this looks like. So if I diagram it, what does this look like? Well, 3, 3 looks like this, right? Okay, so let's see about converting it to polar coordinates. So we're going to find r first. R is equal to the square root of x squared, just 3 squared, plus y squared, which is also 3 squared. So r is equal to the square root of 9 plus 9, or the square root of 18, which reduces to 3 square root 2. When you break this up as 9 and 2, then you square root the 9, it becomes a 3. Now the theta, I'm going to use the trick here and say arctan of y over x, which is just arctan of 1, or 45 degrees. 45 degrees. Well, what I want to do is I want to check to see if this lines up. So if we look, this is in the correct quadrant. So we do not need to do an adjustment here. All right. And I gave no domain restriction, so this is totally fine. If they gave you a specified range that your theta had to be between, sometimes you have to do an adjustment. All right. So let's do another example. Let's do 5 square root 3, comma, negative 5. Okay, so again, x and y. Oh, sorry, I should write the final answer for this, which is 3 square root 2 r, and theta, which is 45 degrees. 45. Sorry about that. Okay, so we're going to find r in this new case here. So r is equal to the square root of x squared plus y squared. Okay, so this is going to be square root of 75, because you'll square the 5 and the 3, so that'll be 25 times 3, or 75, plus negative 5 squared, which is 25. So this is going to be square root of 100, or just 10, which is nice. We like that a lot. And then I'm going to find my theta. And I'm going to use these wavy lines here to be like, it should be something like this. So we'll do tan inverse of negative 5 over 5 square root 3. And when we do that, probably using our calculator, we get something like negative 30 degrees here. So one answer for this problem is 10 negative 30 degrees. And if we diagram this point, that actually works out fine. Okay, root or 5 root 3 over, 5 down. So it's right here. It's in the right quadrant. Sometimes, though, there's like a domain restriction or a range restriction on what the thetas can be. So if we were given that theta had to be between 0 and 2 pi, then this would not be legal. So what we would have to do is to find an angle that is coterminal with this. But we know how to find coterminal angles. We would just wrap this all the way through. So we would add 360 to it, making this 10 330 degrees, which would be an alternative answer, but equally as good. And you may not have to do this if there's no restriction on what your angle is, but sometimes there are restrictions on the angles. Okay, let's do a couple more. So let's do the point negative square root 2 square root 2. All right, so I'm going to diagram this one first. So negative square root 2 square root 2, we're over here in quadrant 2. And what we're going to do is use the same conversion factors we had before. R is equal to the square root of x squared plus y squared. Okay, so this is the square root of 2 plus 2, which is the square root of 4, which is just 2, which is great. We like these nice clean numbers. And then theta is going to be something like the arctan of square root 2 over negative square root 2 y over x. Okay, so when we do the arctan here, we get negative 45 degrees. Now our r was positive, so let's think about where this is going to lie. So this gets swept out negative 45 degrees from the positive x-axis. So we're doing this, and then we're venturing 2 out like this. So if we look where this lands us, this is not in the right quadrant, right? This is not good. So what we need to do is we need to boost it around to the other side. So when you're in the wrong quadrant, a lot of times you'll just have to see that, oh, I'm over here, I need to be on the other side. So what we'll do is we'll add 180 to this, right, to push us to the other side. So if we do negative 45 plus 180, we get 135. Okay, so our answer here should be r, which is 2, and 135 degrees. Okay, so one last one. Negative 4 square root 3. And again, this is x and y, so we use our conversion factor, like so. X squared is negative 4 squared. Y squared is negative 4 square root 3 squared. So this is the square root of 16 plus 48, which is 64, or the square root of 64, which is 8. So this 48 is because when I square this, I get 16 here and 3 here. So when you multiply those, you get 48. So our r came out really nice again. Let's go for our theta, which is going to be something like arctan of negative 4 square root 3 over negative 4. And when we do the arctan of that in our calculator, we'll just get 60 degrees. Okay, well, let's diagram this guy. We should always diagram it to see if our theta is correct. So our point is negative 4 root 3, which is somewhere down here. But this angle puts us over here in quadrant 1. Well, that's definitely not right. We can't be pointing this direction like this with magnitude 8 in that direction. We need to be on the other side. So what we're going to need to do is boost this around 180 degrees. So we're going to add 180 degrees here, and that'll give us 240 degrees. So we'll have our r, which is 8, and our theta, which is 240 degrees. Excellent. So we can do more of these examples if we need to in another video, but hopefully you can work them out from here. So just remember that you just need to find r and theta. R is just the square root of x squared plus y squared, and then theta is going to be something like the arctan of y over x. You may have to do an adjustment if the angle lands you in the wrong quadrant, like it did in these two examples here. Okay, thanks.